evening, everyone. This is Channel 7 News. I'm Abriel Williams.
And I'm Mackenzie King. Today we have come to you with exciting news on recent advances in science and an update on happenings around the world.
The civil rights movement is in full swing today, as one young African-American lady has refused to give up her seat to a Caucasian rider on a Montgomery City bus. Currently making headlines is the usage of the word teenager, which refers to any youngster between the ages of 13 and 19.
Also, we have news of the first hydrogen bomb being developed.
In other news are two scientists, Alfred Hershey and Martha Chase. In 1917, you recall a scientist by the name of Felix D. Harrell, known for discovering bacteriophage, or eater of bacteria.
Harrell realized that his discovery would aid in fighting off diseases. Today, Hershey and Chase have used this very discovery to determine bacteriophage's genetic material.
We now go to a clip of Mackenzie, who had an opportunity of interviewing Mr. Hershey.
Mr. Hershey, thank you for being on the show. So, what exactly was the procedure for conducting this experiment?
First, we established that the goal of our experiments was to determine the genetic material of bacteriophage. We wanted to decide if this was either DNA or protein. We conducted our experiments on the T2 phage. When the phage attaches to the outer membrane of a bacterium, it injects genetic material. Thereby, the phage leaves its empty shell and infects the bacterium. Our first set of experiments consisted of labeling the phages with phosphorus-32, which is radioactive. Once the phages infected E. coli, we could observe the transfer of P32 labeled phage DNA into the cytoplasm of the bacterium. During our second set of experiments, we gained support for our hypothesis. We were able to see that the genetic material which infects bacteria was DNA, as opposed to protein. This was done by labeling the phages with sulfur-35, which is radioactive. Sulfur appears in cysteine and methionine, both amino acids. However, it is not present in DNA. My assistant, Martha Chase, and I conducted a low-speed centrifugation which separated any attached phages. After whirling in a blender for several minutes, forces from the blender broke the virus particles away from the bacterial surface.
Well, that is very interesting. Is this where you drew your conclusions? What exactly were you able to draw from this experiment?
Why, yes. At this point, we concluded that viral DNA enters the bacterial cell during infection. Also, we concluded that viral protein does not enter the bacterial cell during infection. Therefore, DNA must be the viral genetic material.
Well, it's been excellent talking to you, Mr. Hershey, and once again, thank you for your interesting recap. I'm Mackenzie King in the studio with Alfred Hershey.
Keep up the good work, Mr. Hershey. We wish you all the best of luck in the future. I'm sure you had a blast meeting him, Mackenzie.
Oh, what a time it was, Abriel.
Now we'll take you inside of their laboratory for you to see just what we're talking about.
In the Hershey-Chase experiment, bacterial viruses, called phage, were used to demonstrate that DNA is the genetic material. The phage used in this experiment consisted of a DNA molecule surrounded by a protein coat. When phage infect bacteria, they attach to the surface of the bacterium and inject the DNA into the cell. The protein coat remains on the outside of the cell. In the first part of the experiment, phage were produced in a medium containing S35 radioactively labeled amino acids. This resulted in a phage population with S35 labeled proteins, but no radioactive label in the DNA. The phage were then allowed to infect the bacteria. The phage attached to the bacterial cell and injected their DNA, but the radioactively labeled protein coat remained on the outside of the cell. The phage produced in these cells contained no radioactivity. Vigorous shaking caused the empty protein coats to be removed, but did not interfere with production of new phage in the cell. In the infect the bacteria. The phage attached to the bacterial cell and injected their DNA, but the radioactively labeled protein coat remained on the outside of the cell. The phage produced in these cells contained no radioactivity. Vigorous shaking caused the empty protein coats to be removed, but did not interfere with production of new phage in the cell. In the second part of the experiment, phage were produced in a medium containing p32 labeled deoxyribonucleotides. This resulted in a phage population with p32 labeled DNA, but no radioactive label in the protein.
Keep up the good work, guys, and we will keep you updated on this story. Well, that's all we have for today, folks. Turn in tomorrow at 10 for more interesting stories.
Once again, I'm Abrielle Williams.
And I'm Mackenzie King.
And this is Channel 7 News.